Okay, so this is one of those cumulative kind of questions where, first of all, you have to kind of interpret the question correctly in terms of what the reactants are and what the products are. So if something is formed by the reaction of, the thing that is formed by is going to be a product, okay? So get that the right way around. By the reaction of blah, 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 and blah, 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 that's going to be reactants, right? Other things you're being tested on is nomenclature, right? So like if you asked about like dinitrogen tetroxide, you're going to have to translate that into a chemical formula. If you're given state symbols, you're going to have to include them. And if you're given like an ionic compound, then you're going to have to make sure you write the correct electrically neutral formula for it. So solid sodium chloride, let's get that right first. So sodium is cation, right? Chloride is the anion, so hopefully we're quite happy with sodium chloride being NaCl, and we're told it's solid. So solid sodium is going to be NaS, and then chlorine gas, we need to remember our 7 homonuclear diatomics, and chlorine is one of them, so it's Cl subscript 2, and we're told it's gaseous. Okay, so get your reactants and products on the right side of the equation. Write a skeletal, as in unbalanced equation. So sodium solid plus Cl2 gas goes to form NaCl solid. So it's not balanced. So then we have to start doing balancing. So do your bit of accounting. We got 1 times sodium on this side, 2 times chlorine. And on the right-hand side, we've got 1 times sodium. And we've got 1 times chlorine. Okay, so we know we've got to end up with more chlorine. So you can either use the fractional and put a half in front of the Cl2 and then times everything by 2, or you can be like, well, I've got to have more chlorine here, so I'm going to put a 2 in front of the NaCl. So I've got to update here my counting. I've now got 2 sodiums and 2 chlorines. Oh, so my chlorine is correct, but my sodium is out, so I've got to put 2 in front of my sodium, update my counting, and then I'll get the same answer that I got 2 sodiums on this side. Okay, so let's have a look at another one and make sure we are able to do this. Oh, lovely, some molecular compounds. Okay, dinitrogen pentoxide, so that is going to be N2O5, and it's a gas. Okay, it's produced by the reaction of nitrogen trioxide, so 1 nitrogen 3 oxide gas, and nitrogen dioxide gas, NO2 gas. So what are the reactants? Dinitrogen pentoxide is produced, so that is a product, okay? By the reaction of nitrogen trioxide and nitrogen dioxide, those are going to be reactants. So NO3 gas plus NO2 gas goes to form N2O5 gas. We're told those are all gases, right? So is this balanced? Well, that would be anticlimactic. So we've got 2 nitrogens on the left-hand side, and we've got 5 oxygens on the left-hand side, and that matches the right-hand side. So you don't even have to balance that one. Wow, you got let off easy. Let's do another one. Here we go. This is more fun. We've got an aqueous solid iron. So iron, remember, is Fe. Okay, so FeS, and aqueous magnesium chloride. Okay, so remember, magnesium is Mg2+, chloride is Cl-, and it's aqueous, so it's going to have an AQ symbol. So what is this magnesium chloride going to be? Well, it's going to take 2 Cl- to balance out 1 Mg2+. So it's going to be Mg Cl subscript 2, okay? 2 chlorides for every 1 magnesium, okay? And then the reaction of solid magnesium is going to be Mgs, and aqueous iron 3 chloride. Iron 3 means Fe3+, and chloride is Cl-, so iron 3 chloride, it's aqueous, is going to need 3 chlorides to balance the iron 3+, so FeCl3. Ooh, okay. So solid iron and aqueous magnesium chloride are produced by, so those are products. So the reactants are the solid magnesium and the aqueous iron 3 chloride. So Mgs plus FeCl3 AQ. So again, skeletal equation, not balanced. We can do that in a minute. Gives me solid iron, so that'll be FeS plus aqueous magnesium chloride. Oh, this is a good one. Okay, so it's not balanced, right? If I could type that in. So let's do some bookkeeping. We got 1 magnesium, we've got 1 iron, and we've got 3 chlorines. Ooh. And on the right-hand side, we've got 1 magnesium, and we've got 1 iron, and we've got 2 chlorines. Chlorine, not balanced. So this is a great time to do lowest common multiple. Okay, 3 times 2 gives me 6 chlorines. If we've got 6 chlorines on each side, we'll see what happens to everything else. Okay, so I'm going to times this left-hand side by 2. Okay, so I'm going to end up with 6 chlorines, but don't forget that's also going to mess with my iron. Okay, so now I've got 2 iron. Don't worry though, because we've got iron and magnesium present as just atoms, so I'm sure we can fix it later. Okay, and then I was going to times this right-hand side by 3 for the chloride, which means I'm going to have to update this to 3 chlorines. Sorry, 6 chlorines. 2 times 3 is 6, right? And then the magnesium has gone off. So that is going to be 3 magnesiums. So that's going to then be quite easy to fix, because I could just make 3 magnesiums over here. Well, I got 3, and then I can make 2 ions over here. Oop, I got 2. Okay, done. All right, so get some practice with that. You're practicing several things in this question: naming, a little bit of reading comprehension, and a little bit of equation balancing. How fun!